All right. So, obviously the big sort of story here is going to be this sort of transition component. The story here is not that we think that countries are typically at their steady state. That's not the idea. The idea is that the economies are always moving towards their steady state, and there still is going to be this sort of dynamic process going around it. Curves are going to be shifting. Countries are going to be becoming more productive, right? I mean, just think about that sort of particular idea. There can be this sort of sense, I think, when we sort of first kind of learn so for example, right, in the basic setup here, we have capital per worker here, we have output per worker here, and so the economy has a level of production, the economy has a level of savings, and then one of the things that can happen is that the economy can become more productive over time, and so maybe productivity shifts up there, and then this causes also a shift of the savings as well. And so you can see, for a sort of given level of depreciation and population growth here, that we're going to increase the steady state. So the steady state shift, from here and now moves out to here, right? So steady state shift. So it's not that there is one steady state and the economy is always going towards it. It's that the economy is always going towards a steady state. But we also sort of get sort of sense that the steady state is also changing or at least having pressures put on it from particular places. So I just wanted to kind of sort of set that stage a little bit, and have you start thinking in terms of transition, and then to also think about this in terms of our simple numerical example that we had before. Let me just plug in my computer here before it dies. There we go. Okay, so before we had an economy with this production function, output per worker, with a savings rate of 20%, and then both population and depreciation rates of 10%. We know that the steady state capital in this economy is 4. Okay. Now, but what we're going to say is that for now, the economy is operating at 2 units of capital per worker. So it's below its steady state, right? Solow model is going to predict that this economy, as it moves towards its steady state, it's going to increase its capital per worker stock because it's currently below it. So we should see capital accumulation, from one period to the next. So let's just set up a very simple kind of 2-period setup here. We can define the change in capital per worker as just capital per worker in time period 2 minus capital per worker in time period 1. And then we can also go ahead and define what capital per worker is going to be in time period 2, because we know what that is. So capital per worker in time period 2 is just going to first be capital per worker in time period 1, the existing capital stock from last period, and then plus, and I like to think about this next piece as sort of just the adjustment mechanism, if you will, in the economic system. And the adjustment mechanism here is defined by the savings rate times output per worker minus, and then depreciation plus population growth times capital per worker, right? So I like to think about this as just the adjustment mechanism, right? This is the extent to which the economy is adjusting as it is moving towards its particular steady state. So we can do some simple plug and chug here, and we can see that in time period 2. So we're going to start with the existing capital stock, which again we've set as 2. So 2 units of capital there, plus, and like I said, we're just going to plug everything in. So 20% savings rate. We know that output is capital per worker raised to 0.5. So that's just going to be 2 square root of 2, and then minus 10% times 2 capital per worker. And so we just do the math here. 2 plus, let's see. So 20 square root of 2 is 1.4. 20% of that. I'm going to round a little bit, so that would be 0.28. and then minus 0.2 here. And so therefore we get 2.08. So as we can see, the change in capital per worker is just 2.08 minus 2 equals 0.08. And so what this means is that when the economy went from time period 1 to time period 2, it added, 80% of a unit of capital, I guess is the way that you want to think about that. Now, we could move on into the next time period, right? So we could do time period 3. Again, we start with capital there plus the adjustment mechanism. We can get that in a second. So K3 here is going to be equal to 2.08 plus, and then we just have to update everything, right? So 0.20 times, and then we have 2.08 square root plus, and then 0.10 times 2.08. Boom. And then you just do the math, so on and so forth. And then, of course, this is going to continue until we reach that particular steady state. So one sort of interesting thing you can work through is like, how long does it take? If everything stays the same, how long is it going to take the economy to reach its steady state? That's kind of an interesting question. But we're not really so much interested in that question. What we're rather interested in is the economy moving towards, in a sense, the right steady state? So let's introduce the idea of golden rule steady state. So in a sense, the way we're going to think about steady states is like we've thought about anything at this point. There's going to be an optimal steady state. And we're going to further define the optimal steady state as the steady state that maximizes consumption. Again, this goes back to this idea that the Solow model is about quality of life in the context of incomes and consumption. So the golden rule idea is that, okay, the central bank can affect S. Okay, the central bank can affect S. So let's think about S for a moment. So let's think about the ways that the central bank can affect the savings rate, right? Again, think about this in terms of what we know to be true, at least in terms of the theoretic underpinnings so far discussed in class. So, for example, like what affects the savings rate in the current time period? Well, one of the things that we know that affects the savings rate in the current time period is going to be the interest rate, right? So we can think about the real interest rate here as affecting ultimately the savings rate. And so we know that the central bank can affect real interest rates through different monetary policies. And so we can affect the savings rate. We can increase the savings rate. We can decrease the savings rate. So the argument is going to be in the Solow model that the economy is always naturally moving towards a steady state, but that there's going to be a particular steady state that would be the optimal steady state for the economic system. And we have a fairly kind of straightforward idea as to how that is. And that's going to be the steady state that maximizes consumption. Now, mathematically, that could be a little bit sort of confusing at first, how we kind of might conceive of this idea of maximizing consumption. But let's just start, from the idea that we have output, we have investment, SY, and then, of course, the difference in these at any particular capital stock is going to be consumption, right? So this is investment, savings times output, and then, therefore, this is going to be consumption. So the idea is that we want to affect the savings rate that gets us to the steady state that maximizes consumption, right? So if we just put let's put a depreciation line there, depreciation plus N times output per worker. So again, we could, if we want to increase consumption or whatever, we can affect the savings rate. So again, the idea is we want to be at the steady state level. which ultimately is going to maximize consumption. So the question then sort of is, okay, how do we do that? How are we going to maximize consumption? And we get a pretty sort of straightforward kind of idea here, which is that if we want to maximize the vertical distance between these two curves, we want to maximize the vertical distance between output and savings for any given level of savings, then what we need is we need the slope of the depreciation line to be equal to the slope of the production function, right? So what does this sort of mean then? Well, what is the slope of the production function? Slope of the production function is going to be the marginal product of capital per worker, right? So we need the marginal product of capital per worker to essentially be equal to the depreciation plus population growth rate, because that, of course, is what defines the slope of the depreciation line, as it were. And so really the trick of the golden rule is finding the steady state level at which the slope of the production function is equal to the slope ultimately of the depreciation line. And so in that sense, the conceptually, it's pretty straightforward. Mechanically, there might be some question there as to how you would actually kind of pull that off. But again, just conceptually, in terms of how the math sort of ends up working out, we get this really nice kind of property as to how that would actually kind of occur. So you can, again, the mechanism here is pretty straightforward. We're going to move the savings rate either up or down to achieve this golden rule level of steady state capital. Again, with the idea that the economy is naturally moving towards a steady state. So all we have to do is then pick the right savings rate. Now, I'm not arguing that that's easy, but that's the trick here, is that the central bank would target, in a sense, a particular savings rate relative to the current conditions of the economic system. And then the idea would be is that if you get the right savings rate, you then get this golden rule effect, and you ultimately maximize consumption. And so, yeah, the sort of interesting thing here, but there's a real practical sort of idea, which is that if you think about this in terms of like optimality in economic models, there's always sort of this like on the margin, we're looking at marginal things equaling each other, right? Marginal benefit equaling marginal cost. We saw this in terms of other parts of the classical model. And so here you can see that on the right, this is, the extent to which our existing capital stock is being used up in a way. And then marginal product capital is the extent to which the using up of that capital stock produces output. So it actually should make a lot of sense in just a basic sort of economic reasoning that the extent to which capital being added to your production function is leading to output per worker, that in optimality, that is going to be the extent to which capital is being used up, right? So marginal benefit equaling marginal cost. It's a classic first equimarginal principle, right? This is why we teach that basic idea and sort of keep coming back to it. So that's the same exact idea here. And it's important, again, to say and reiterate, we don't expect the economy to naturally move towards golden rule. This requires the central bank to understand both where the economy currently is and also to have an idea of where they want the economy to go. Now, again, we really want to think in terms of sort of the transition. So, for example, let's go to a sort of another way to think about it. Let's think in terms of being above the steady state golden rule. So let's say that we have capital per worker here, output per worker here, and then let's say that we have okay. And then let's just go ahead and we'll define ultimately the golden rule. We'll define it right here. So we'll call this golden rule steady state. But then the current steady state in the economy is right here. So we'll call that regular K. So you can see that the trick here is going to be plus in K. The trick here is going to be to lower the savings rate in the economy, right? In a sense, to get the economy to consume more than it currently is consuming. And also, that should make sense because if we're currently above the golden rule, in a sense that the investment relative to depreciation is too much relative to that golden rule position, in a sense, we are overinvested. We're overinvested in the sense that our consumption is actually being hurt by the current level of capital stock per worker. And so, from a policy perspective, we actually want that capital stock per worker to decline, and that will then translate into actually higher consumption, which again is a little bit counterintuitive. But so ultimately, moving in this sort of particular direction is then going to put the variables on paths, right? So let's think in terms of output. So output starts up here. So we'll call this Y1. And then we can see that as we transition to the steady state, right, the savings rate doesn't affect output in terms of the production function. So the production function does not change. And so if we were to shift the savings rate down here, so S prime Y, again, to get to golden rule here, then what we can see is that output is just going to steadily decline until we reach that steady state, right? So we started here, and then here's the golden rule. So it just sort of steadily declines, right? Now, look over here to the left and look at output. You can see the dynamic path is that at the moment in which we achieve golden rule, or I'm sorry, at the moment in which we reduce the savings rate to achieve golden rule, we expect output to steadily decline. And of course, by the time we get to golden rule level of output, we will have reached lower output, right? That's important here. It's important to point out that golden rule can be less output than you currently have. So a key idea that keeps coming up in all of these economic models is the goal is not just raw economic growth, right? The idea is to sort of work within the limits of your economic system to produce, in a sense, the efficient outcome, where the efficient outcome is defined as sort of the best possible outcome given those particular sort of ideas. All right, now let's look at consumption for a moment. It's a little bit more complicated to see that, but let's work through it. We know that consumption is just the difference between output and investment. So initially, we can see that consumption starts up here. So we can call that consumption. So the difference between output and investment in time period one, if you will, so we'll call that time period one, is C1. And then what you can see is that as we move towards the steady state, this golden rule steady state, I should say. So we'll call this CR golden rule here, or golden rule consumption. You can see the consumption has gotten bigger. And in particular, you can see that consumption has gotten bigger while output has slowly declined. At the same time, we can see that investment has also slowly declined. So that's going to tell us kind of the sort of initial versus more dynamic changes, right? So we get this initial decline in investment caused by the lowering of the savings rate as the central bank tries to achieve golden rule. That initial decline in investment is going to cause an immediate increase in consumption, right? And then as we transition, what we see is that the extent to which output is falling relative to the extent to which investment is falling it's falling at a faster rate. Right, and you can see, so as we move here versus as we move here, it's at a steeper place. So that's why consumption, and you'll notice it goes up and then it starts to decline, although it stays higher than it was before. That makes sense because we were not at golden rule before, but it gets initially higher and then it sort of declines. The reason why it declines is because both output and investment are declining, but the extent to which output is declining is faster than the decline in output. So that's why consumption also happens to be trailing off. And of course, we can see that there in terms of output. So in fact, the way this is drawn here to the left, you should see that the drag on output is less than we can see the drag on investment. belaying the idea that output is declining in that particular way. And then if we get to sort of the exact opposite way, if we start from the perspective that we need to increase the savings rate, again, you sort of just want to work your way through these sort of particular transitions. And you can see a very similar story, except sort of opposite. The interesting thing here is that if we're below our golden rule, then policy not only gets us to a higher level of consumption, but gets us also higher consumption, higher investment, and higher output. Whereas if we're above our steady state golden rule, then getting to it hurts output. We consume more, but our output is hurt. So in a sense, economies don't really want to ever find themselves above their golden rule. In a sense, you always want to kind of be below it. And I think that's generally also just true of steady state. I think countries would prefer to always be below, working towards, as opposed to being above and working back. I like to think about this in terms of golf. So, I know not everybody plays golf, but a big sort of idea in golf is like you have, let's just say you have your green here. So let's say your hole is right here. There's the golf hole. And so typically the way greens work is that there's sort of this area kind of around the hole. And you once you kind of go in this direction, very often the ball sort of slopes away. So if you hit your ball over here and you have to hit it back towards the hole this way, you have to hit downhill, right? Because the way the greens typically are is they're slow. So you want to kind of keep the ball here. You want to keep it they say below the hole. You want to keep the ball below the hole, and that way you don't have to then putt downhill. That way you're in a sense always putting uphill. So I think about that in terms of the Solow growth model, right? There's a real benefit to never overshooting your steady state. There's a real benefit to never overshooting your golden rule. And in the same way that we talked about, there's a real benefit in not overshooting your aggregate demand increase in terms of inflation expectation. So we get a different kind of economic model here, but a lot of the same sort of lessons is that the economy has to be very calmly managed. So if we are going to do something like push the economy towards golden rule, we have to kind of be very cognizant of how difficult that's going to be, and also that over the long run, we don't want to kind of constantly having to be moving back. We don't want to have to be sort of overshooting golden rule and then, in a sense, bringing the economy back down to prevent these particular problems. In the same way that we don't want to probably be overstimulating the economy in the short run to the extent that we're always having to fight inflation. And in a sense, we want to choose a more optimal policy path that kind of keeps the economy just below that kind of inflationary pressure. And so here you get kind of a very sort of similar argument.